Hey everybody, can you all hear me? Just want to do a quick test of the sound. First time I'm doing this, so it's kind of gonna be an interesting experience. You're gonna have to bear with me. So, thanks for taking the time. I have a lot of slides. I think I went a little out of control with this whole topic. I'm gonna try to go through them pretty rapidly. I'm gonna kind of keep an eye on the chat, so if I'm going too fast or something's not clear or whatever, I think it's better to just like poke me or whatever, and I'll try to elaborate more. I'm gonna try to do this a bit more loose. It's not gonna be like a talk or a GDC presentation or anything like that. It's more just like literally just a brain dump. So we'll just get right into it. Basically, introduction. Some of you know me, some of you don't. I'm a technical architect at a AAA game studio. Been working in AAA for around 10 years. I've been lucky enough to work with a lot of different technologies. The first thing I worked with was Glacier 2 at IO Interactive. That's also the Dawn engine that IDOS uses. And then at Ubisoft, I got to play with Dunia, Anvil, whatever the Watchdogs, it's Dunia, but they rebranded it to something else. And the last sort of 5 years I've been working with Unreal. In the spare time, I've kind of played around with CryEngine and what is that, Stingray. I've been playing with the Our Machinery a little bit. Ironically, the one thing I don't have much experience with is Unity, but we'll see how that goes. I've also been kind of firefighting for roughly a decade. I've gotten the ability and kind of, whether it's a good thing or not, I've touched literally everything in an engine apart from audio and UI. So these are sort of areas that I have experience with. For the most part, I've actually written implementations of most of these things, either during work time or for like my home engine. As such, I have a lot of more high-level experience than, let's say, a lot of systems programmers that are kind of mostly focused on the low-level engine kind of programming tasks, optimization, that kind of stuff. I've had to work at the high level, so providing tooling, gameplay systems, dealing with designers, iteration times, those sort of things. So what is this topic on? Basically, I needed a fun project at home. I'm building a hobby engine just to learn and play with. And I've been struggling with sort of these things at 3 different companies now. Every time it kind of almost works, but then we have either performance problems, iteration problems, reusability issues, scalability. It just tends to be a giant pain in the ass. So I picked it as a nice topic. I had to build it anyways and kind of fucked around with it for 2 years. Started with something I knew from Glacier, which I found to be kind of elegant, hit massive walls with that approach, switched to one of the game object component models, which I kind of really hated given that's what I've been working with for the last sort of decade. And then there's massive issues, which we'll get into. Messed around with ECS, kind of moved away from that as well. And now I'm kind of on some kind of a hybrid, which is what I'm going to use to describe kind of my personal thoughts on the whole thing. So before we do that, we're going to go through the game object component model, which is the standard thing. It's sometimes called the entity component model, which gets super confusing with the ECS thing. So I'm going to just kind of stick to just calling it game object component model. I don't want to use the word entity and component because it's going to get a little messy. We're going to take a break after we're done with that. You guys can ask some questions. I'll try to answer as much as I can, and then we'll run quickly through what I have in my home engine, which is sort of a hybrid approach. That kind of tries to resolve a lot of the issues with both of these. And then we'll do another round of questions at the end. So hopefully this won't take too long, but no promises. I have 130 slides to get through, so we'll see how that goes. So jumping right into it, what is an object entity model? Fundamentally, it's how you describe your scenes. It's the base building block for your levels, for your gameplay, for basically every aspect of the game. Now, it also defines how your scene is updated, because since those are the basic blocks, it defines sort of update. It defines the relationship, how these between your objects, like how is a door hooked to the AI? How does an AI drive a car? How is a particle system attached to the mesh? Those kind of things. And I'm going to say things that'll probably piss a lot of people off doing this. One thing we seem to forget a lot of the time with game engines and game engine tech is that we're supposed to build games with this, and there's supposed to be a user. It's not there to build a fucking tech demo. And a lot of some of these approaches, they're great for a tech demo, but they just, as soon as they hit production, it's going to collapse. So I'm going to talk about sort of pragmatic real world use cases. As I said, people are going to get a little bit annoyed. I don't particularly care. I deal with day-to-day problems of gameplay programmers suffering with tech, designers suffering with tech. We have iteration times. We have problems with cyclic dependencies, load times, all this kind of bullshit. And a lot of the time, these models make it really difficult to reason about how we work with code. So back in the day, I actually have an old book that I dug out called C++ for Game Programmers. I'm not actually sure what year this thing was published, probably early 2000s. But inside of it, you can see kind of in the screenshot how they would structure game objects. So you'll see we have explicit objects for flying AI, hybrid AI, land AI, moving AI, all these kind of things. And this is kind of how we used to do things. You know, we would have a vehicle object, we would have a door object, a light object, all these kind of individual kind of setups, which were kind of bespoke. You would handcraft it, you would build it exactly as you needed. At the end of the game, you throw it all away. Next game you start, you kind of see what you can reuse, so on. It doesn't really scale. It works for a project, perhaps. But if you, let's say, make a racing game and then you decide to do a third-person shooter, I'm not too sure how much it's going to transfer. It has some of the general... Oh yeah, the No Lopus book, I guess. There was 2 editions. Sorry, in the chat, the book. Yeah, there was 2 editions. I think I have the super old one. So big problem with this thing is you end up with sort of deep hierarchies. If you remember back in the day, one of the big problems people were saying about OOP was, oh my God, the hierarchy is super deep. It's impossible to reason about. Everything inherits from everything, virtual calls, blah, blah, blah. That's true in this case because it's kind of there by design. You also end up with this diamond inheritance problem. Personally, I hate multiple inheritance. That's the one thing, if I could remove out of C++, I would, and I would just have more interfaces, just like how C# tend to do it. This approach also tends to result in a lot of duplicated code. If you try to avoid diamond inheritance, sometimes you end up having to duplicate certain codes, or you start creating mix-ins, and you kind of start losing track of everything. And again, all your standards are OOP shit. So one thing before we get into this whole thing, there's no standardization for any of this. You know, I'm talking about ECS. ECS is like 50 flavors. The game object component model has like 50 flavors. You know, even the names are really difficult to sort of agree on. Even the game object component model, some people call it game object component, some people call it entity component, some people just call it a object model. Some people don't even have a name for it. It's just something that's part of the engine. So I'm just going to discuss like the most common patterns I've seen. Again, it's not going to refer to any specific engine. It's just more stuff that I've seen across the years. So the most common one is the game object component model. This basically is an object that actually owns components. Basically what happened is we took the old door, vehicle, what have you, object, and we split out shared functionality. So we took stuff out like, well, this code manages the movement, so I'll make a movement component. Or this code manages the behavior of the AI, so we'll put that into a behavior component. So you take something like a player character, And then you split it out into like camera component, movement component, weapon component, health component, etc. This is sort of by far the most common model. It's used at Ubisoft. It's used in all of Ubisoft's engines. It's in Unreal. It's in CryEngine. It's Lumberyard. Pretty much most engines use some variant of this system. Everybody's kind of seen it in some form or other. The game object usually has a name like pawn, object, actor, entity, something along those lines. Ideally, it should just be a generic thing that basically just has a list of components, and the components have all the logic and the data and so on. Realistically, that's not the case. Most of the time, the game objects themselves have their own updates, and internally they have their own updates and just order stuff like this. And we'll get into why that ends up happening. And sometimes the component themselves may or may not have an actual update. That depends on the engine. For example, Unreal has an update for its actors, but its components will also update. And the actor itself doesn't update its components. The components register into a task graph, so on. Some engines actually have an update function that literally then runs through all components and calls update on them. Again, engine dependent. And the game object can then have references to other components and other objects. So you can have cross-object dependencies and cross-component dependencies. Now, what is a component? Basically, it stores data. So it has stuff like references to like resources, it has settings, it has runtime state. And in the game object component model, it also has the logic. So this functions to update, this get setters. It's kind of an OOP approach to this is an object, we have its data, we have its updates. It's sort of self-contained and atomic. Now, these components can also reference other components, and they can reference other objects. And this is where stuff starts to get messy. We also seem to still have hierarchies. So in a lot of engines, you'll still have the game object, and from there you'll derive certain things like boss pawn or player character or AI character, which is a game object. It has all the inheritance of the game object, but it has some special case stuff. Components obviously have inheritance, and we still have sort of some degree of a inheritance tree. Now, this isn't necessarily bad. I'm not one of those people that's like, oh my god, OOP bad. I personally don't mind it as long as it's done sort of sensibly. The hierarchy is not necessarily a bad thing. There is many cases where you want to reuse stuff, or you have pretty much identical code that you want to share across multiple of your components, or you have some syntactic sugar that you want to share. So be it. Not necessarily a bad thing. Another thing that the game object component model usually features is a spatial hierarchy. And this is something that's relatively important. So what do I mean by that? It's basically the concept of a spatial component. That is a component that actually has a position in the world. It's actually in the world scene. It's not just a abstract entity. So for example, in UE4, we have the spatial hierarchy defined by scene component. So a scene component has a transform, and everything deriving from scene component has a location in the world. So I did a quick example in Unreal. In this case, we basically have a character that is highlighting the spatial hierarchy aspect. We have a capsule, we have a character mesh, we have a hair mesh, we have some armor, a gun, and some attachments. So in this case, our character is now composed of a capsule and 5 skeletal meshes and a static mesh. So this is kind of should be obvious to everybody. This is kind of standard for everybody. We attach meshes to other meshes. We attach parts to parts. We do composition of characters in this way. And here we have one game object, one character, all of its data. So some of the benefits, well, they can describe an element in its entirety. As I alluded to earlier with the character, basically that character object contains literally everything that character. If that character has 5 weapons, I can put those 5 weapons in there. If it has 12 meshes, I can put the 12 meshes. I can even build sort of prefabs inside of one object. I can have a desk object. And that desk object could have the desk mesh, it could have cups on it, it could have boxes. So be it. This is conceptually simple. It's very easy to understand. Hey, I have a desk. I have a cup on the desk. The cup belongs to the desk. That mental model is very simple. You can add what you want to it, and you're relatively done in terms of a setup. It's very easy to create tooling for it. As again, you have a simple mental model. It trends very easily, and it's kind of analogous to a scene tree approach. Again, back in the day, we had these giant scene trees. This is sort of an extension of that, where we're basically cutting out branches in that tree into an object. Now, coming to the issues. Everything kind of boils down to the same thing, and that is reference hell. The updates and initialization order and everything, again, boils down to the same reference problem that we're going to go into in a lot of detail. The minor issue is, again, cache unfriendliness. I'm using inverted commas there because this is a big argument about, oh my God, ECS so much better. In profiles and in the data structures and in sort of the stuff that I've seen, I'm going to not lean too much of this as a major issue. I think both can have similar problems. Our data in gameplay is by definition unfriendly to the cache. I'm not sure the object model can solve that, as we're going to get into the ECS side of things later. So what are these problems with the object component model? Primarily, it's those two functions, get owner and get component. So by design, all these implementations that I've seen have cyclic dependencies built in, where in any component I can say, give me the owning entity. And from that owning entity, give me any other component. Or I can go to the world and say, hey, world, give me every other object in the world and let me access one of their components. And so basically everything can reference everything. And everything usually does start referencing everything. As soon as like gameplay programmers get thrown in this with design iterations and deadlines, every project ends up sort of like this. And I'd like this to be a joke. Unfortunately, every sort of programmer that's been in the shipping team and dealing with performance issues in the last like month or two is usually crying because they start pulling on one little thread and they pull half the fucking game code. And this is something I think all of us have relatively dealt with at some point. Give me 1 second. I'm going to grab a hoodie. I'm kind of freezing. One isn't living in tropical Montreal. So we're going to take a very basic example to highlight these problems. Let's say we have 4 components on an entity or an object. We have a mesh component. We have an animation component, basically does something, it doesn't matter what, and spits out a pose. We have a physics component that has a ragdoll. That ragdoll basically updates the bodies. Let's say they're being moved kinematically for now. There's no simulation. They're like hitboxes, pretty much. And then we have the cloth component. What that does is it takes a pose. It then runs a cloth using the pose and the physics body of the character to basically have the cloth collide with the character and look nice. Kind of a relatively basic AAA setup for a character. So there are 2 major fucking problems with this whole thing, with this object component model. And those 2 are 1, initialization order, and 2, update order in the data transfer. So let's talk about initialization, since that's, I'm going to say, the simpler problem. So in this case, the order of initialization is, because we have sort of dependencies between these components. For example, the skeletal mesh component has to initialize first. Then we have to initialize the animation component so that we can set the initial pose on the skeletal mesh. Then we need to initialize the physics component so that we can kind of read the pose and set the physics bodies. And then we need to run the cloth, basically to generate that first pose for the character, again, based on the character pose and the ragdoll bodies. So, kind of simple, right? We have the 1, 2, 3, 4. We have the set pose, get pose, set pose, get pose, and sort of the implicit get the physics bodies. That'll be via the physics scene, so it's not an explicit dependency here. Right, kind of simple to everybody. Next question is, how do we actually do this? How do we actually make sure that we can ensure this initialization order? Right, I just have an object with components. I don't know what component needs to be initialized at what stage and how and what order, right? There's no mechanism for this. So a bunch of engines hack this. They do multi-stage initialization. So they'll create something like, in Unreal, for example, there's on register, there's an activation stage, which is an optional thing, but it's not symmetric, so you're never guaranteed you'll get a deactivate call. Initialization is the same thing. It's optional, but then sometimes you don't get the de-initialized, I think what they call it. And then you have begin play, where you actually do get the end play. And so you have multiple stages, so you can kind of hack your way through that by basically saying, well, on unregister, I'll do the skeletal mesh component. On activate, I'll do the animation, and then on begin play, I'll do the cloth and then this. Right, that kind of maybe works a bit. It kind of becomes a nightmare because as you start adding more components, they add more dependencies, and then at some point you're going to end up with a cycle, or you're going to get some sort of a conflict. Constructors, Siddharth is asking, constructors don't really factor into this because usually to initialize something, you need to have loaded the resources. So you need to have actually constructed the object, deserialized the settings into that object, into the component. And once you've deserialized the data, then you can initialize it. So initialization is more like, hey, I have my data. I need to now create runtime state like a pose storage. But to calculate the pose storage, I need the mesh, I need the skeletons, and those kind of things. So as I was saying, as you add more components, they might have other dependencies. So maybe now something interferes with that initial 4 component setup. And guaranteed you're going to hit a cyclic dependency. So what do you end up doing? Well, this is where now we start with the derivation of object types. So you'll take your game object, you'll derive a new type called myActor, and you'll do your component initialization manually. And at that point, we're back to like the old school approach. Except now we've got the illusion of modularity because we have components, right? Components are modular. Solution. People should be used to this kind of code where we create our components, at some point serialization runs, and then we call init or whatever your engine is doing. And then we initialize them in the order we want. And we can kind of control which order, how, and that. And then every time we add a component, we manually kind of mess with this until everything works. So what happened to the modularity? All right. We thought we were modular, but now we still have to go back to handcrafting everything. We basically just sort of got separation of code now, which isn't necessarily like a bad thing, you know, and it's probably worth doing in the overall case, but it's not exactly like this great modular approach that kind of we can data drive everything. So let's talk about updates. So the update order now is not the same as the init order because we have to run animation first. We run animation, we get the pose, we set it on the mesh. Once we have it set on the mesh, we can set it on the physics component. We get the mesh pose, we set it on the physics component. Now, first thing here is I have it set that the skeletal mesh component is setting it on the physics component. It could be the animation component, right? This is where we start to run into problems. And now cloth is the last thing in the chain, right? Okay, so we could do it this way. We could have, okay, well, once the skeletal mesh component has a pose set on it, we can basically then set the pose on the physics and the cloth component, and then we have to make sure the cloth component is scheduled to run at the physics component. And once the cloth is finished, it then sets the pose back into the mesh component because the cloth component is just a sim, and it actually doesn't have the mesh, so it sets the bones back on the skeletal mesh. Cool, now we have a cycle in there, right? Because if we look at the dependencies, well, the animation component needs to know about the skeletal mesh component. Skeletal mesh component needs to know about the physics and the cloth component. Physics luckily doesn't have any dependencies, but then the cloth depends on the skeletal mesh component, which also depends on the cloth component. So we have a cycle there, and that's a bit of a fuck up. In this case, we can kind of fix it by just inverting some of the calls so that the cloth component can now pull from the skeletal mesh component and then push onto the skeletal mesh component. So now the dependency is only from the cloth onto the skeletal mesh component, and we've removed the dependency back. There's a thing here about setting the pose. For example, a skeletal mesh component might have multiple set pose calls done in a frame. So you may have, for example, your facial animation setting a pose, your character animation setting a pose, procedural animation setting a pose. So you kind of want to do them multiple times and then have the skeletal component at the end of all its poses, then trigger the next thing. So now we have the dependencies between those, and we have to schedule this, right? So again, it's like we have these dependencies in terms of update order and in terms of code. And the shitty thing about this is it's implicit. This is unknown. There's no way. You have a component. How do you know what it depends on? And anybody that's kind of worked in these systems will have seen code like this everywhere. You know, get components. If it's null, do something. If it's, you know, if it's not null, do something. If it's null, just skip or return or whatever. This is sort of an implicit dependency on something that only code knows about and hopes that your setup matches this. And if it doesn't, it either crashes, errors out, does nothing, maybe does a log, and then you have like 12 million logs that people ignore. This is kind of really, really shitty for numerous reasons. And it gets worse if you start looking at gameplay code and it starts looking like this. That, like, I've seen code bases with pretty much half of the gameplay functions start like this. Get me all the components I need. If any of them are not there, just return, or warnings or whatever. And we kind of have to do this because caching components can be really bad because we actually don't have ownership on them. And maybe the owning entity decides to destroy a component or rebuild a component or add a new component of a different type or something. Somebody's going to say, well, let's use shared pointers, and then you have another fucking problem because now you might have a pointer to the wrong thing, whereas the owner has, I don't know, destroyed and recreated the mesh component, and all of a sudden you've pointed to something that's bad or not used anymore. And now you have bigger issues. So generally we don't cache, and so we always retrieve it. Now that's a big performance clusterfuck too. Every single function just starting out with a set of what the fuck, you know. That's kind of shitty. So coming back to like the update order. Cool, we know what we need to do. It's relatively simple. I can explain it to you in like 30 seconds. How do we actually end up doing this? Well, we have several ways. We can explicitly define this. Again, back in the old case, character. Inside of my character class, I put in a update prephysics, and then I write all the components I need to update prephysics in there. And I control the update order. That generally works. Now what you could do is you could also add priorities per component. Basically say, hey, here's a numeric value for when you need to run in which stage. Like you need to be in prephysics and your priority is 27. For example, for the animation component. And then, skeletal mesh component, you can be 65. Cloth needs to be late, so 999. You know, it works. But again, you kind of like, it's a bit tricky of when you want to schedule what. And then sometimes you end up with conflicts where you type in a magic number and that magic number conflicts with another magic number, and then you have a issue, and now you have to look at other components and what order are they in. And you can argue that this can be fixed via tooling. That's true. So I don't necessarily find this horrible. Priorities is something we cannot avoid. The issue comes in is when, For an AI, I have a specific order of priorities for these components. But maybe I have a special case boss. At that point, I need to then set up my priorities in a slightly different order because maybe they have a different gameplay setup, or maybe physics has to run at a different stage or something like that. And that's where we have issues, where defining it on a global class basis, it can be problematic. So you can run into some problems, and then you end up jiggling and juggling these things, or you start deriving components just to change the priority number. Siddhar's asking, why would we need to set the priorities by hand? How else would you set them? You could start to do stuff like explicit dependencies of components, but that grows out of hand really fast. And when you have cycles, you can't schedule that. If I have things with conflicting priorities, they'll still run. But if I, for example, have cloth component referring to mesh component and mesh component referring to cloth component, you can't schedule that in a task graph, right? You're going to deadlock. So generally, these kind of things are just done this way because it's simpler and easier. If you've ever tried to debug a giant task graph, it's also, believe me, not a lot of fun. There's another approach. You can unify all the components into one component, and then you don't have to worry about dependencies. Some engines do this. The skeletal mesh component in Unreal does this. It does animation, deformation constraints, physics, cloth, God knows some blend shapes. A bunch of stuff is all in one component with a bunch of ifs, and it schedules like 15 updates, and it's a nightmare to use, because if you want to use just one aspect of that, you basically have to pull the whole thing and disable chunks. It's a nightmare. Don't fucking do this. Like, just don't. Like, try to stay the hell away from lumping 15 things into one place just because you couldn't figure out the update order. So additional problems we have is, obviously, I think the reusability and scalability. We split out a bunch of functionality into different components. It kind of makes the code a bit better because you can sort of compartmentalize things by file or by class or whatever. The idea was to allow more composition over inheritance, so I could just take an object, add the components I need, and I sort of have my my new type. This kind of only works for static setups, like non-characters and non-gameplay stuff. More like, oh, I want to set up a prop or a bunch of trees that wave in the wind, or like prefabby stuff. It's, in general, once you get into more complex scenarios, you end up having these update order problems. You end up having the init order problems. You end up with a lot of custom stuff that needs to be done. Primary data transfer between components sometimes. Fundamentally, all the issues come into the fact that I can reference anything from everywhere. And that's kind of the fuck up. Like, personally, I really like the single responsibility principle. That's sort of how I work. I like to make sure that every piece of code does literally just one thing and nothing else. This sort of model is not congruent to that. It basically is a free-for-all. Ideally, a component would only perform one thing. For example, a physical component would update ragdoll bodies and nothing else. The only thing it would know about is ragdoll bodies, set their positions, run a sim, get their positions. That's it. Nothing else. The problem is now we need to transfer the data somewhere, and that stuff is usually baked into our components, which is kind of shitty. And this is the core of the issue, is that you end up in scenarios where you don't even know what a component is doing, what its side effects are, because you call the update, and next thing it's doing is it's accessing the mesh component and setting state there. And even worse, it could be doing it on a whole different entity, because sometimes we do cross-entity modifications. Like, one entity will animate another entity. And so now you're updating entity A, but meanwhile you're messing with entity B state, which, if you want to parallelize something, kind of a no-no. The other thing is, now we have these implicit dependencies that nobody knows about because somebody wrote get component somewhere in the code, right? There's no way to kind of figure out what was referenced where. Some programmer needed some bit of information for some feature, Just went right in and said, get me this component, get me this data, change some code, submit, done. Cool, we have a new dependency, we don't know about it. One engine I worked in was quite hilarious, where this was so bad that as soon as you added one component, you had to add another component because it had a dependency, otherwise nothing would work or it would crash. And then you had to add a third component because that one referenced something, and that third component referenced, and at some point you had pretty much your base entity had 30, 40 components because everything referenced everything and it would crash if it wasn't there. At that point, what the fuck is the point of having components? Right? We're back to having, you might as well just have hard-coded the fucking thing. In Unreal, there's certain cases where they actually expect an exact setup. For example, if I remember correctly, the projectile component requires that the projectile actor that you spawn has to have a capsule component, and then it has a mesh as a child. You know, it expects a very exact setup. And if you don't have that setup, it just silently fails. And then you have to step through the code to figure out what the fuck is going on. This is not ideal. One option to fix this is to not allow these implicit dependencies between the components. But then you end up doing the data routing and everything yourself. Yeah, Mika, you're right. It is good bad engineering practices, but the problem with this model is because it's so open, it doesn't guide junior programmers or people new to it in the correct direction. It just says, everything's open, have fun. And once pressure, crunch, iteration times, gameplay features come in, people take shortcuts. You know this better than anybody. You know, we have some stories, right? So again, if we go back to the oldie model, we could have just said, you know what, maybe the gameplay component model should just be as I handcraft my actors and I split the components into separate chunks, and then I manually put what chunks I want in which actor, and it's all controlled, and we don't pretend that it's data-driven. This is feasible, right? There's nothing necessarily wrong with that. Yeah, it's not data-driven. Is that necessarily a bad thing? I don't know. But pretending that we have reusability and scalability with this is not something we should really do. Here's a bit of code, sort of pseudocode. There'll be a lot of pseudocode in these examples. Like, it's not potentially the right way to write things. It's just I'm trying to channel a lot of stuff that I've actually seen in code bases. So in this example, we want to target an enemy. So naively, what would a gameplay programmer do? Well, he'll say, give me all the characters in the world. For every character, ignore me, obviously. And let's check the type. So we'll get the archetype component for that character. And we'll say, if it's an enemy, we continue. Well, if it's not an enemy, we just skip it. If it is an enemy, we then check the distance from that enemy. And there we do a get position, which then implicitly requires that there be a spatial component set for that character. So we access that component, we get the data. Then maybe we do line of sight, blah, 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 etc. Then we say, okay, we've got our list of broad-faced targets that we can shoot at. Now let's score them. Well, okay, to score them, we need maybe the aggro, we need the health component. And you can see how this is starting to like touch tons of different components and different aspects of the entity. And at this point, if you start drawing dependencies between these objects, it becomes a spider web. And if you try to thread this, it's impossible because how? I don't know at any given moment in time what's being referenced from which entity, you know, how. And this is sometimes a frustration of mine where I've been in several times now at companies where we have performance problems and somebody says, well, we have more threads, so we should try thread things. And then somebody watches the Naughty Dog talk and says, oh my God, a fiber task system will solve everything. How? How the fuck am I supposed to thread this? Right? And a lot of the times, if two of these characters are trying to shoot at each other, well, they're cross-referencing each other. There is no way to solve this. From a model aspect, this is just basically stopping you from parallelizing in any sort of way. Basically, this is why a lot of engine, you'll see a giant block on the main thread called gameplay. or game sim or whatever they want to call it, and then rendering goes and threads. Yes, you could expose this. You're assuming that the pins and stuff were thread safe. If it's Glacier, that wasn't, and that was a to-do at one point. But yeah, you could expose the dependencies, and a lot of people will say this about task graphs as well. Let's expose explicit dependencies for everything. If you're a gameplay programmer and you're trying to write code, you're focusing on trying to get your feature built. You don't want to now be like, oh shit, I access this component, so I have to go to the definition of this and expose this thing and then make sure that it's a fucking pain in the ass, and it's a massive amount of like overhead. The system should be providing tools for you to do this. It shouldn't be on to you to now, because basically what's going to end up happening is every single game object will expose everything as a dependency. And at that point, you're back to nothing. Does Unreal run gameplay? Yes. Unreal is single-threaded fundamentally. If Epic could design hardware, you'd have one 12 gigahertz processor. Blueprint is restricted to one thread. All gameplay is restricted to one thread because they reference stuff across characters, objects, that kind of thing. They don't support threading. I know that they're trying to get there at some point, but it's going to be a tough fight for them, given the legacy and the code base that they already have. So there's always the one programmer on the project that'll come in and be like, hey, I got a good solution. You know, let's add some singletons. This will solve everything, right? You know, we can use singletons as sort of managers, and we can defer requests, and we can do all this cool shit and, you know, solve some of these dependency issues, where we can have a targeting singleton that basically manages all the targeting in one set, right? Well, they're usually kind of added as an afterthought. They're not part of the system. And a lot of the time they add even more cycles, right? Because everybody's seen this code, get instance, and then you register with your manager. Great. So even more cyclic dependencies now. And then once you have this option, then you have people in the singleton doing some magic and in the object doing some magic, because it starts becoming, yeah, singletons enter chat. Singletons carry bat. And then you have another set of problems, because guess what? Singletons also have to update, and they also have to initialize. And there's a big assumption that they don't have implicit dependency on other singletons, because what stops you calling get instance inside of a singleton from another instance? And you might think I'm joking, but there was a talk from one of the Ubisoft architects about, I think it was Anvil, where they had such a big problem with singleton dependencies that they started creating what they called, I think, singleton storers, which was singletons that would initialize other singletons in the correct order. And once you start down that path, there is nothing but pain. Now, as much as I hate global singletons, sometimes they are a cleaner solution if they're done properly than the direct cross-object access. Because if you're stuck with this model and you need to sort of defer or parallelize anything, you can't do it at an object level, because again, you have these cross-object dependencies. So a lot of times what you can do is you can register requests like, hey, give me a target, and I'll wait a frame and get the target next frame. So you could do stuff like that. Again, you have to be very careful with this. It can work. It's dangerous. It's tricky. If you're not very careful with the data access and ownership, you end up in a lot of pain. And it's a massive, massive foot gun for juniors. Like in most of my reviews, ownership of data is the biggest issue. It's why is this variable in this struct and not in that struct when you're using it only in this context? Or why is this function exposed globally instead of just being in the translation unit? Why is this a global variable that anybody can access from everywhere instead of just being, you know, an anonymous namespace in the CPP, you know, that only used an F1 function or just statically defined in that function? All these kind of like, who owns the data? Who can access the data? How is that data available? You know, a lot of the times these days, we kind of forget we're making software, I think, in games. And getting something on screen is a lot more important. So we will rush things just to get something working, and then say we'll clean it up later, or it's just a prototype. We'll do a second version, and we end up shipping the prototypes. Mika will remember that I think we shipped Proto Combat 2 as the combat system in Hitman Absolution. So it wasn't even the first prototype. I think it was the second prototype, and we never got around to actually doing the real thing technically. So my mentality these days is pretty much just what you build is the final thing. There's no prototyping. There's none of this, oh, we'll do a second pass, we'll clean it. No, you make sure that that damn thing is extensible and clean the first time around. You're never going to get another chance. And as I said, over time, even with the best intentions, you start to build this stuff and it becomes a massive spider web, which frankly becomes impossible to untangle. At the end of Hitman Absolution, we will move to a new project. And we decided that we have bigger ambition. We needed to do a bunch of changes to the AI, the this, that. So we said, okay, we were hitting a big problem with this tangling of data. For example, I remember one class with the ragdoll, the character would call into the ragdoll component to initialize the ragdoll, which will call back into the character to get the skeleton, which then called a function on the ragdoll to get the bodies. And we spent something like 3 months with two of us trying to split this, and we failed miserably. And at that point, we just started rewriting all the core systems and started porting whatever code we could of each system. But there was just no way to untangle what was there. And at that point, you just don't even bother. Just either you start fresh or you just live with what you have. And most of these problems are just due to the fact that there's no guidelines within the system, and everything's freely accessible and globally accessible in many cases. In Unreal, it's potentially even worse because at any point I can get the world. Yeah, I am describing Unreal 4. You can get the world, and from the world I can get any single other object, and I can do whatever I want with that object. And in a lot of cases, all the variables, everything is public, so I can even fuck with internal state, which shouldn't be allowed because sometimes you can't even set the state individually. You need to run through a function because that changes multiple things, but they allow you to modify just one variable, so you can end up in a pretty much in an invalid state of that object where you can't now even destroy it because it crashes because you've modified one thing without the other thing. You need to be very careful. You need to know what Unreal is doing to minimize those problems. It's something that you have to keep an eye out, and primarily you have to read a lot of code and try to figure out how they're using those features themselves and stick to their mentality. As much as you say, well, I know how to do it better, I want to do it better, you need to respect the engine you're working on and work in the way that they work, even if it makes you uncomfortable. It's the safest way to move forward with Unreal. Don't fight it. Just either build on top or around it. Don't change it, or don't try to change it. You're just going to end up in a lot of pain. And to that point, a lot of time spent with this model is actually fighting the model or working around it. So we're going to talk about ECSs now, and this is where things get controversial. I'm not going to spend too much time on this. This is actually something that's relatively well documented. There is a bunch of write-ups, both from Unity side, there's Unite talks, there's a bunch of ECSs on GitHub. The BitSquid guys, or what they call now, Our Machinery, they did a bunch of talks on this. They've done a bunch of write-ups, blog posts. There's a lot of info on this, so I'm not going to go into too much detail. It's gaining popularity, but despite what you might think, it's not very popular. And I don't know of any AAA engines apart from Overwatch that has an ECS in it, in terms of what most people commonly call an ECS. Stingray had it, or BitSquid, that engine had it. So stuff like Vermintide shipped. Mika says they do. Unity has it. It's been experimental now for 3 years-ish. But it's definitely not something I would say popular or something that shipped a lot of things. People are using it. It's becoming an interesting topic. Yeah, I think it's preview or experimental or something like that. I don't know the state of it in Unity. So what is an ECS? Basically, in this state, there is no game object anymore. An entity is an ID of some type. Again, I'm not going to go into too much definitions because it starts becoming a religious argument and there's like 50 fucking different versions. The basic concept is that there is no actual object. Components are also now pure data containers. They don't contain any logic. This solves the initialization and the update order problem, primarily because they don't update, and the initialization is purely localized to the data in there. So if you need to initialize a component, there's no dependency on anything else. You can just, the order doesn't matter. So that's great. This solves it. Logic is now moved into the systems, which is basically it's just splitting the class into two. And the systems operate directly on components. So one of the easiest ways of explaining what the ECS changes are is pretty much this. In the object component model, you have a struct and you have logic and data in the struct. In ECS, you still have your struct, but now you have an external function that operates on the struct. That's fundamentally the distinction. The idea being is that you've decoupled your logic from your data. Now, in reality, we'll talk about that in a bit. So these systems, they're global component managers fundamentally. They're basically singletons, except they're systemic singletons in that you define a singleton and it operates on all components of that type. Basically, all of the update logic, everything resides within these global managers. Again, every ECS does it slightly differently, but fundamentally there is a signature that basically says this system operates, it requires these three components to exist on an entity. So for example, it's an animation system. It might need an animation component and a mesh component. And then it can run a logic of updating animation and then setting a pose and whatever needs to be done that way. So you would have a system A that would then match some set of components, and those components, if they match an entity, that entity is registered with that system and it runs. These systems now remove the implicit dependencies because you've turned them into explicit. You basically are saying, I need to run this logic if this entity has these components. And that's a really kind of cool thing to do because everything's explicit. I know exactly what data everything needs. It's kind of an elegant approach. But we have some issues there too. So because we have these component signatures, it sort of limits the ability to derive systems and sort of extend systems and change custom logic. Now, maybe there's better ways of doing it. This is the only things I've come up with. So let's say I have a system. We're going to go into a bigger example here, but I derive some components. Those components will now match signatures for both a base system and a derived system. Maybe I need the derived system to work on some derivation of those components, but not in the base class, right? Or then you can say, oh, we'll just use the most derived type. But then if you use the most derived type, if you derive a new mesh component, well, you have to go to every other system that uses mesh components and also tell it, by the way, you need to use this most derived type, or it's a type this, or it's a type this. You know, basically your signature matching becomes more complex. Again, that's kind of given with inheritance. You could go crazy and use a DSL, like a domain-specific language, to define your component signatures. For example, component A needs to match this subset of types, and component B needs to be only this type, and component C can be either this type or this type. Yeah, there's going to be some issues going down that route, and the complexity is going to shoot through the roof. If you want to derive a system, you have the exact same problems. So I'm going to go through an example of that. Let's say, very simple problem. I have two components, X, Y. I have a system A that works on X and Y. Now, I have two entities which have those two components, but I need custom logic on those two entities, right? Not a crazy approach, This isn't a super esoteric request, super feature. For example, they say, well, I need some boss to basically behave the same, but kind of different. So same settings, same values, but I need the logic to be slightly different for this boss fight or something. How do we do that? Well, I could try to create a new system, right? I'll just create system B. But now I have, yeah, I'm getting to the tag components. Yeah, I'm getting to that part, Josh. Don't worry. One option is you create a new system, and now because the signature has to match, well, you basically copy paste the components, and you have I and J, and now you have a new signature and a new system. It works, yay! But now you've basically duplicated the code just to get a signature match. This also prevents you using those components in other systems that might use them, because again, we don't have exclusive usage of these components. So now you have to modify those other systems to handle these derived types. This is not a good approach. The other option is the tag component or something, where you would create a new optional component that potentially will specify, hey, use logic 2 instead of logic branch 1. And then the component signature on system A can be either X and Y, which will run the default, or maybe it's XYZ with this new component. And then you would check the value of Z and say, oh, this thing is of type blind. Inside the system, you would branch. Cool. You're adding new components just to basically direct flow. That seems sketchy. You could have a shared component of the graphics mesh, and each mesh would get its own select. Sure. But again, okay, I'm going to talk to Mika's things first. Yeah, okay, no deriving. How do I do the logic then? If I want to change the logic with 2 different structs, how do I specify that, the system A on this entity now needs to do a different thing when the component signature is identical? You could put flags in the components, but then you're bleeding functionality into that. Yeah, that's what I'm saying. You would branch in the system. In the system, you would branch on something, and that branch is either a value on the component, or it's a new component or something. And at that point, you start creating a shit ton of different little components that are very bespoke to a specific use case or a specific system or a specific piece of logic in a system. And now somebody has to know what combination of which components do what in which scenario. And that adds, again, cognitive complexity. Maybe for me, I'm too stupid to understand that, but yeah. There's issues with this approach. Generally, B is the thing. You add tag components, you add branching components, whatever. Again, not a bad thing. It does add complexity, and it does add more memory to access, because those components are not in the same memory locations as the original one. So, ooh, what happens to the cache? Right? Because ECS and cache. Right? So now if I have 27 of these components, oh, great, I'm hitting 27 different memory locations. Awesome. Just to read a fucking bool or a tag or something. And then also your system starts to become kind of large, where they're branching internally. And there, again, you end up in problematic cases where you might end up stepping on each other's toes. One guy decides to modify something for his use case, puts it in the wrong function or in a base function somebody else is relying on, and it didn't test. And again, this is more user error, but it happens. And again, the system doesn't explicitly provide a mechanism to do this cleanly. Now, the biggest problem I find with this approach is the fact that most of the popular ECSs have a limitation in terms of having a single component of type per entity. So you are only allowed 1 transform component per entity, or 1 mesh component per entity, etc. There's a good post on the Our Machinery discussing single multiple. Most decide to go with the single route because it's simpler. This implies that there's no spatial hierarchy anymore within a given entity. So if you want a spatial hierarchy, this is now cross entities. And you start using link or attachment components. So for example, if we look at the comparison of the game object model with the ECS approach, In the one case, I have one object that contains my character. And in the ECS, I have 5 entities. And I have 4 attachment components that now specify that, hey, this entity is now attached to that entity at this socket or this offset or whatever. Right? Cool. 5 entities, 5 separate, distinct entities are now one character. That starts to become a headache. I wrote a big question about this, explaining some of the problems with something like a character customization system where, think of an RPG. Again, not an esoteric use case, relatively standard problem. We have a character, we want to customize them. They have a head, torso, arms, hands, feet, Each one of those now becomes a new entity. And our character becomes 10 entities. And let's say we decide to do something like Escape from Tarkov, where they have a crazy gun thing. The gun becomes 20 entities. At which point does this start to... This is starting to spiral a little bit. If I want to get all the elements of character, I might now have to composite 20 entities together and do constant lookups and this and that. It becomes problematic, and it also becomes mentally taxing to start to kind of track all these components. And if you start having to do operations across all of these components, you start to have issues. And the other thing is with the transform aspect of this is that with no spatial hierarchy, let's say I want to access the transform of a specific part. Let's say I want to take the sight of the gun. How do I know that the will transform is accurate at this point? Right? I have to get the will transform firstly. How do I do that? Well, I have to now get that information from its parent entity, which might have a parent, which you start having to look at all these things. So you have 3 options, kind of. You can kind of assume all the transforms will be frame lagged or wrong, which is probably not a good idea. You can try to update all children every time a transform changes, which means that, like, okay, I change a transform, I have to now find if there's any entities attached to me and then tell them that, by the way, my transform changes, so you need to update your transform and kind of push that down the pipeline. Again, these hierarchies are, you have to do constant entity lookups. You could also do the opposite, and is just every time I ask for the will transform, I go up the hierarchy and I try to look up the parent entities every time and try to calculate that chain. I don't see any solution for this in any of the ECSs. The last 2 of the options are kind of the only ones you really have. And you could say, well, we can start caching this hierarchy and stuff, but every frame, your ECS hierarchy can change. And now you have to update your cache. So it's kind of a similar problem. Well, Mika's saying no reason to force everything. Well, that's unfortunately, if you only have an ECS in your engine, what do? You build something in parallel. This is where it starts becoming headachy. It's not an object model then at that point. It's just settings, which, why do that? Then I have to worry about different updates, and I have other systems and singletons and scheduling. And again, it feels the thing. I found this from one of the facts about how to create a hierarchy. They have 3 different approaches, pros and cons. Every single one has advantages. Every single other one has disadvantages. I mean, it's kind of a trade-off. So again, what's the cognitive load of this approach? Well, a lot of the systems now need to understand the simplest hierarchy and deal with it. I mean, people are saying with the ECSs are, no, I need to do character movement. I need to do animation with an ECS. Well, if I have 25 meshes that I need to set an animation pose on, I need to look up those 25 meshes. So every system now needs to understand this implicit hierarchy and look up those components and say, well, give me all the meshes. So I have to now go through all entities and try to figure out which one's attached to which. And I probably need some sort of a hierarchy cache, because that's going to be super slow to always search for this. That cache needs to be updated. I'm adding a lot of complexity for fundamentally a very trivial issue. This is one of the big problems I have with ECS. And again, it's the Wild West. Any system could deal with it differently. I mean, there's no systematic approach saying this is how you do this thing. And the spatial hierarchy is not a strange problem. It's the fucking general case, right? It's literally the general case for most of our gameplay data. So there is additionally the problem of doing the update order issue of I have multiple systems. Those systems potentially, I have multiple entities, and those entities are attached to one another, but they have different logic. They need to run independently. I need to now schedule this entity to have its system run before this entity or so on. And I can't really reuse systems there because now the systems have to be running multiple times and do grouping and scheduling. So I'll do a very simple example. I have a tank. Again, these are not very esoteric cases. They are games with tanks out there. I have three main parts of the tank: a chassis, a turret, and a machine gun. You could say make one skeletal mesh and problem solved. Cool. But what if we have customization? Or what if I can switch out my turret with a rocket turret? Or, you know, and what if these tanks are supposed to have special AI where the turret is tracking independently? There's a bunch of different use cases where having them separate makes sense in terms of separate updates, not necessarily objects or whatever. Now, I need to update the chassis first, then I need to update the turret, and then I can only update the machine gun. Because again, there's a spatial hierarchy here. And targeting, if each one of those things is trying to target something, well, they need to know their position in the world. I need to move the tank. I need to change the rotation of the thing. Then I need to rotate the turret, and based on that rotation, I need to rotate the machine gun. It's a simple thing. You can go back to the old model for this. An ECS still allows you to create a tank system that basically takes a tank, finds all of the entities for it with some tag components or whatever. Basically, every part of your tank will have a tank component, which will have an ID to other entities in the tank component and so on. You could do that. It kind of does go around a lot of the ECS kind of paradigms. It's doable. Maybe it's valid. Don't know. The other option is you could create multiple systems: a chassis system, a turret system, a machine gun system. How many systems is your game going to end up having at the end of the day? Like, I've talked to people that have shipped with an ECS and they have something like 60, 70 systems. Maybe that's okay. I'm worried about the maintainability of this in the long run, because those systems, again, decoupled. Well, decoupled is a strong word because they're not actually decoupled because they use the data in the components. You modify the component, you have to modify the system anyways. They're not decoupled. The code is just not in the struct. You can't fuck with the struct and expect the systems to magically work. Well, okay, so 70 sounds very few. Okay, maybe it's even worse. And at that point, it's kind of hard to reason about what needs to run when and what does what. And maybe again, this is a personal opinion. Maybe I'm too stupid to get this. I have a hard time kind of trying to build a mental model and reason about this. Holy shit, Mika's saying 400. I mean, yeah, I'm not too sure that's, anyways, wow. So we need to talk about the elephant. Let's talk about performance. ECS is now being promoted by certain people as performance by default. Or, oh my God, I will get so much performance if I switch to an ECS. Why? Why does everybody say that? Primarily because everything is in arrays. We have flat arrays and we iterate over just the components and the components in the cache because, you know, I'm updating all my transform components in a row and I'm never cache missing and everything's right there when I need it, right? Yeah. Well, this also gives you another reason why you don't want to derive components, because then they go into different arrays or tables or whatever you want to call it. Cool. So that's the idea. How many actual systems can really leverage this in a real game? Not a tech demo, not a Boyd's thing. So let's take an example of a AAA open world game. We might have something like 250 mesh instances. You have, let's say, 7 cells loaded. Each cell has 40, 50, 60, 70,000 mesh instances per cell because you have, I don't know, let's say you're doing Cyberpunk and every building is made out of kits and every building has procedurally generated pieces based on kits or whatever. So you have shit tons of these little meshes. How many of these meshes are actually dynamic? How many of these are dynamic? Maybe we have, I don't know, let's say 100 characters, and each character is 10 meshes. Okay, cool. We have 1,000 meshes. Great. So we have 250K transform components with only 1,000 of those that we need to update every frame. And let's also make a massive assumption that we run the exact same code in every single one of those 1,000 transforms. Let's say they're just voids. They're just simple agents that just move, right? Cool, we make it best case scenario. How can I guarantee that those 1,000 components are in the right place and contiguous in that 250K array? That's even if it's a single array, which I think some ECSs use linked lists of tables or something to prevent reallocation and copies or whatever. Can I even guarantee that those 1,000 are in a row? I'm pretty sure I can't, because those things are dynamic, and depending on streaming in this, they might pop in at one point, then a cell loads, and then you have another 50,000, and then something else pops in. Okay, great. So the contiguous argument kind of goes out the window there, because I'm going to be jumping around potentially. Maybe it's in the cache already. You know, you don't know. Cool. Are we constantly sorting that array to make sure that dynamic and the static are separate? Do we have separate storage for dynamic and static? Well, we're not talking about mesh components and dynamic mesh components. We're talking about transform components, right? Because in an ECS, you have a transform component. Your mesh doesn't have a transform. So you have a generic transform component. How do I know a transform is static or dynamic? How do I sort that array? Right? I can come up with solutions for all these problems, but there's a lot of complexity coming with these issues. And the assumption is, well, it's in an array, it's fast. Okay. I'd like to see that. So another issue is that the systems generally, in like a lot of the ECSs, they run sequentially on one thread, and then they go wide within the system. So the idea being is you do a parallel for. I'd probably not store an ECS. There's no problem. So Florian says he probably not store the meshes in ECS. Well, let's say in the dots model in Unity, your meshes are going inside of your ECS. Same thing in our machine or wherever. You're defining your scene in your ECS. Your ECS is your scene format. A lot of engines that go with an ECS, instead of an object model, they don't have another representation of the scene. So yeah, your meshes are going in the ECS. Unless you do something like you create a multi-mesh holder that then, you know, holds all of your scene geometry with all the transforms, but you're fighting the ECS at that point. You know, you're not leveraging the system, you're just fighting it, or you're working around it. Okay, but coming back to this, like the systems, they go wide internally. At least that's the idea. And you look at the Unity examples, whatever, they basically do a for each or whatever. It kind of makes sense in many cases. But again, I'm going to say this, we're not making particle systems or void sims, right? So how many players do we have in a game? Usually local players. Generally one, right? So I do a parallel for of one for all the player systems. Okay. How many cameras do we have in the game? Usually only one. You know, and again, all the camera stuff. Can't really parallelize that. It just runs. Let's assume we have position updates, right? So at least those, according to all of the examples that you see about ECSs on the web, I can apply these to all the entities, right? How many of those position updates are code-driven? How many are they even running the same code-driven logic at the same time? How many of them are anim-driven? How many are physics? How many are just attached to other entities, right? What am I parallelizing? Right? This will probably be 4 or 5 different systems. And each one then is branching and then trying to get its thing. You can't run systems in parallel because you have then dependency between systems because they touch the same components. Right? If 2 systems match the same signature, they hit the same components, you can't parallelize that. So is the performance coming from the ECS or from doing sensible things with your data? Well, you can if you can schedule them. And then you may end up with, again, depending on your dependencies, you might end up with gaps. Or, you might still have a bunch of threads just because, one system is finishing up and the other ones all have dependencies onto it. Again, it becomes a task graph problem, which, yeah, exactly. There's solutions. There are solutions for this, but you have to have problems. The issue is that this becomes complicated, like fast, for benefits that are arguably not as tangible as people are claiming they are. That by default, if I have an ECS, everything works. Yeah, if you spend time scheduling your systems, create dependency chains, all this kind of stuff, yeah, you can do it. How complex is your system going to be? And can the average gameplay programmer work within that system at that point? But people forget that, again, we have to make games with this tech. So can the average gameplay programmer manage, or is he going to drown in this complexity? Because I get a headache sometimes with trying to model this on paper. So I don't know. And to be frank, we already use ECS-like approaches for things like particle systems, renderers, physics, those kind of things. People have kind of mistaken ECS for DoD. We already do these kind of flat arrays, caching proxies, a lot of this kind of stuff already. And for gameplay, I mean, we generally have lower numbers of these objects, and we generally solve cache and friendly problems. If anybody's trying to write something like a achievement system which requires gameplay telemetry, good luck making that cache friendly. There's a lot of these things that people don't think about that are annoying, like achievement systems, progression systems, ability systems, all this kind of stuff that makes the game, but it's just, there's such low numbers of it that you can't even like parallelize anything because there's just not that much to parallelize. The other thing is, like I said, ECS isn't DoD. We need to stop mixing these things up. I mean, we already heavily leverage DoD. The fact that, for example, something like Unreal can run at a very decent frame rate in in sort of like scenarios that are built to tailor to the engine. And pretty much every engine out there that's shipping games, some really impressive ones, with the game object component model where, technically we're cache missing and everything's horrible, we're already leveraging the DoD in renderers, in particle systems implementations, in animation systems, all this kind of stuff. We're already doing this. We don't necessarily need the ECS part. So it's like, so if we talk about, just summarize quickly, there's a massive paradigm shift. There's no spatial hierarchy. It's basically a single-to-learning approach in terms of you have these systems that run, and they can be a very high cognitive load. At least, again, personally for me, there's a high load of me thinking of my character as now 20-something entities. That's difficult for me to manage. So for example, if I have a customization system, I now need to make sure that I collect the right entities, don't miss something, make sure it's tagged correct. There's a lot of extra complexity adding into a lot of these very basic problems. Whereas, for example, in the game object model, I can just say, hey, for this actor, give me all its meshes. It's kind of there. So the other big problem is there's no clear guidance. Every tutorial out there pretty much just gives you a Boyd's example or a particle system example and says, oh my God, performance, ECS, right? I've yet to see a clear gameplay tutorial on it with actual, like, the boring ass fundamental gameplay systems like achievements and camera stuff and sort of like ability systems and all that kind of like AI targeting and all this kind of stuff. Like, right? So that being said, there are good ideas. Yes, there's a spatial hierarchy. It's there could be. You can do whatever you want in ECS, right? I mean, there are good ideas. They remove the initialization order fuck-ups. They remove the implicit dependency screw-ups. They generally result in sort of less dependencies. Though in a real system with a lot of these, let's say 400 separate systems, I don't know how decoupled things are. I'd actually be curious to see what happens if I start messing with component data, how much of the code base I'm going to end up affecting. Because again, the coupling is still tight. I can't modify, it's just like C. I modify a struct, I'm going to have to modify the functions that operate in the struct. You can't get around that. So that went a bit longer than I expected. I think I was answering questions in the meantime. So I think we can maybe skip over the question time, and I'm going to go straight into the next section, if that's okay. Yes, no, or do we want to take like a 5-minute break? All right, let's take a little bit of a break, and then I'll go into... So let's take a quick break, and then I'll just basically give an idea for maybe an alternative solution or something a little bit simpler that could work. If anybody wants to ask any more questions, feel free. Well, thanks. It felt more like it's a bit of a brain dump. It's kind of interesting. A lot of people lately I see on Twitter are always kind of maybe interested in doing game tech or game engines, and they start working and they immediately start hitting these ECS talks and slides and stuff, and they jump on that bandwagon. And I kind of find it frustrating a little bit, because within a couple of weeks they start hitting these issues, and then they either get burnt in the concept or they struggle, and then it kind of puts a bad taste in their mouth, and that's kind of unfair in like beginners. Yes, you're not limited, but again, depends, as I said earlier, depends on the ECS flavor. In most of the popular ones, you are limited. In Unity you are, in our machinery you are, in a bunch of different ones you are. Some of them allow you to have multiple, they have different trade-offs to allow that. So again, it's your mileage may vary. My point was more that, like, I work with junior programmers a lot at work. I think a large part of my job is actually mentoring, reviewing, teaching, guiding, that kind of thing. And hell, even the component object model for somebody that's fresh is difficult, and to just build a mental model of all the different pieces, how the data flows, this giving them an ECS on top of that, which has an even more kind of abstract approach, it is just a massive cognitive load onto somebody. And we're already struggling with technical programmers. Like, these days, people are taking game programming courses, those kind of things. They're skipping a lot of low level. They're not really touching hardware. They don't understand a lot of that aspect. Hell, I'm not even super strong with the low level stuff. I'll be entirely honest. I know enough to be dangerous, but like that. But we have programmers coming in from university that don't know what a pointer is. And now trying to give them these super complex systems, which kind of almost expect a lot of predefined knowledge, is scary. I'm scared it's going to burn a lot of people, and I'm scared that what the Unity stuff is going to do is going to put a lot of people off. And I'm actually going to wonder if they actually roll this out as their primary object model, which is what I think they're aiming to do long term. I wonder how many people are going to just switch to Unreal just purely because they're going to start hitting walls, they're going to start struggling. Because again, the target market for those engines isn't like the tech programmers, it's people trying to get into it, indies, smaller studios, maybe not the most technical teams, right? And that's kind of a concern, because a lot of these issues, if I mention them, most people just say, well, but performance. Okay, great. Well, we should just be making asteroid games then, right? It's like some of the problems we have at work. I've been lucky enough that I've had to now touch pretty much every aspect of our game tech for gameplay. I'm in a situation where we don't have a lot of senior people, and so I've ended up having to architect or build a lot of the core systems myself. So I've been lucky enough to have a very broad experience set now for gameplay in terms of gameplay systems and all that kind of stuff. And there's a lot of really boring, not ideal, great things, that tasks that people have to deal with and build. Like, again, achievement systems are a giant pain in the ass to do. Progression systems are a pain in the ass. TRCs. What else? Like, there's a lot of those kind of things that people forget to think about, but they still have to be built. Pad input, yeah. Oh my god, like the amount of information there is out there on controller input and filtering stuff is like non-existent. And those kind of tasks are hard enough as is, and annoying enough because they touch everything. Like an achievement system will literally touch all your gameplay. Yes, you don't have to run everything with an ECS. I agree. Problem is, it shouldn't be then sent as a, oh my god, this is going to solve performance in video games and you should use it for everything. Because that's what a lot of people are saying right now. And a lot of newbies are running into that trap where they're like now saying, well, if an engine doesn't have an ECS, it's shit or it's bad performance or whatever. Yeah, spiderweb dependencies are bad. I agree. They're a big issue. And that's why I hate that fucking game object component model. It's a fucking nightmare. Especially in an existing code base that has several years of like people hacking and shipping stuff with it. At that point, you just massage it and hope it doesn't like keel over and die. I mean, when I was at UB, I was on Rainbow, and I'm seeing code from Prince of Persia, right? Because that engine back in the day was used for Prince of Persia, and nobody can remove it because if you remove it, something explodes, and nobody knows why. The same was true of Dunia, which was fundamentally a CryEngine fork, and there's code in of Watch Dogs. There's Far Cry code. I'm trying to think what else uses Dunia. It's mostly just Far Cry and Watch Dogs. And in Far Cry, there was code from back in the day, Far Cry 1, Far Cry 2, that nobody can remove because if they do, the engine explodes. And nobody understands it anymore. Nobody wants to touch it, and it's there's no good solution to this, to be honest. I'm pretty sure with an ECS you can make just as big of a mess and just as painful to work in. As I said, if you have like multiple systems all touching the same components, I mean, is that necessarily all that much better? You try to modify one thing, who knows what happens. Anyways, let's carry on. I'm gonna try speed this up so I don't waste your entire afternoon. Kruger. So Kruger is my home engine. It's basically just a prototype engine that I fuck around with in my spare time, just to play with ideas, learn, try new things. At one point, I needed an entity model. This is where this whole thing came from. It's been now 2 years I'm fucking around with different things. My goals were primarily that it needs to be simple to understand. It needs to be simple to debug. It needs to be simple to develop. And for me, this is an artificial one. It has to scale with core counts, ideally linearly. So a bit of a tangent, like we all know clock speeds have plateaued. We know cache sizes and core counts are increasing. 6 core is now considered a mid-range processor. On the desktop, like consumer, you can get up to 16 core processors now. I think an ideal game engine that's kind of future-proofed is one that like can scale with core count and not just rendering, which, to be honest, people are telling me that you still can't really thread that. So in essence, basically multi-threading is important and something that we need to kind of think about. So how do we do multi-threading? Well, there's a couple of different ways to do it. The first one would be locks. They're simple. They're simple to use. They're relatively safe. They're relatively cheap. I know, if they're used correctly. Though, obviously, they can result in bad performance like everything else. If you have bad access patterns that result in high contention, you do stupid things, you end up in deadlocks. Generally, they're not as bad anymore. But again, you have to be cognizant of how you use them and where you use them. You know, the other option is the simple one. It's basically you split your data into dependent chunks that have no dependencies, and you can just run them in parallel with no need for locks or anything like that. That's kind of like the ideal case of like, hey, I have stuff I need to crunch through. It has 0 fucking dependencies. It just crunches for X amount of time and it's done and I'm happy. This is kind of the SPU kind of approach where we used to kind of DMA data on, run it, and then DMA it back. This is not really applicable in all cases, since it's not necessarily possible to remove the dependencies. And the third approach is lock-free, which just don't. Like the number of people that understand the C++ memory model and all the fucking necessary magic and rituals and shit to get this to work probably can be counted on one hand. It's impossible to debug and reason about. It's like hardware dependent in some cases. It's honestly just don't. Maybe you're super smart and a genius, but yeah, good luck. So as I said, it needs to scale with core count. In my case, what I decided is like I set myself some dumb goals. I said, okay, I want entities to be atomically updatable. I don't want any dependencies between like entities. I want to limit the amount of dependencies I have. And I want to be able to trivially parallelize my entity updates, sort of to do a data partitioning approach, but at an entity level. So the entities don't have cross dependencies, everything works. So I built a hybrid. Now, both models have problems, as we've established. Both models have good things. I'm not going to pretend that I'm smart and I know better than everybody else and everything. I'm going to try to find something that's in between that makes sense to me and tries to minimize the headaches I have in both approaches. That's kind of mostly my philosophy these days. And I'm going to just go on a tangent here because like lately it's starting to piss me off a little bit. There's a lot of programmers that are very arrogant and think they're smarter than everybody else. And so they can discount a whole field because they know better. For example, oh my God, if you use OOP, you're a fucking idiot. And slow code, unmaintainable, blah. I've used OOP and I've seen OOP cases that is elegant. It makes sense. It's clean. It does what it's supposed to and it works. I've seen fucking C-style data-oriented shit that's undebuggable. Right? I'm not going to say, oh my God, C is impossible to work with. Fuck, you're a moron if you're using C. You know, it's this kind of mentality of like, well, A is infinitely better than B, so A is the only thing we use. Or, you know, ECS is better than game object component, so fuck game object component, we just do ECS. That's kind of, if you do that, you're just shooting yourself in the foot. You know, it's arrogant to think that all of a sudden you know better than anybody else and that every person that used that game object component model was a moron before you, because you know, that thing was built for a reason. It exists for a reason. People are using it for a reason, just like OOP. Yeah, it's got issues. What doesn't? Like, anyways, bit of a tangent. It's just like, if you want to understand something, read into it, look into it, try to use it, get an understanding of it. And a lot of the time, if you step away from fanboyism and that kind of thing, you might actually see that like things make sense. They might have issues, but they do make sense. So what did I end up coming up with? Well, fundamentally, it's a game object component model. You know, it's got an object, it's got components, spatial hierarchies, components have logic, they're not purely data. What I did do is I removed all the interdependencies between components and entities. And I use systems from the ECS land as an interconnect. And the object updates are strictly controlled. So in my case, an entity is an actual object. It has a GUID, it has an array of components, it also has an array of systems, and I'm going to get into that. You cannot derive from entities in my engine. In this approach, that entity is it's a generic thing, but it is an actual thing that has this data in it. What I'm calling a component is basically data storage, as you would expect. I have like serialization code in there. I have resource loading code, everything. Components can also specify if they're a singleton for special cases. So if you want to basically say an entity can only have one of these components, you can specify that at component level and it will restrict it. Components have zero access to other components. They have no access to the entity. They have no updates. You can derive components if you want. That's up to you. The system doesn't restrict you. They can contain logic. I don't see any reason to decouple that necessarily. I think it's an artificial split. I mean, the logic that you would add on a component in my case is logic that applies only to that component and only to the data in that component, right? Because it cannot reference anything else. And so there's no necessary reason to split that off. You're not gaining anything from it. So for example, in my animation graph component, all the graph update logic lives in the component because why wouldn't it? It's literally a black box. You say run graph and it runs the graph and creates some data, and then you can access that data if you need to. So the idea is that these components are black boxes, right? They have inputs, they have some outputs. What they do internally, it's doesn't matter. Entity components can reference resources, just like in every other system. So I have various stages, unloaded, loaded, loading failed, initialized kind of thing. I'll discuss initialization a bit later. The basic life cycle is as follows. Unloaded, we start loading, either we load or we fail, and then we can initialize. Because I have no dependencies to either other components or other entities or anything, initialization order is not a problem. It doesn't matter. The initialization gives me an ability at some point to allocate in transient data based usually on resources or whatever. It's a symmetric API. You're absolutely guaranteed. Yeah, it is a bit of like an active model. It's an active component model to some degree. You are guaranteed to be shut down. All my APIs are symmetric. Maybe it's my OCD or something, but like I hate it when you have an API that sometimes calls this function but never calls the symmetric function, because in this case it does that, in that case it doesn't. And Unreal is infamous for this, and it's a nightmare to deal with like actor lifetimes and object lifetimes because it's not consistent, and you end up having to put the same shutdown code in 5 different places because you're not guaranteed which will be run in which code path in which scenario. And the editor does something different. In the game it does something different. On PlayStation it does something different. Initialization, in my case, also cannot fail. If something's fully loaded, it should be able to initialize. If it failed to load, yeah, there'll be a problem. So let's, basic example, skeletal mesh component. I basically need to allocate post storage for the mesh. So initialization, I have access to the mesh resource. I can then allocate the memory. And at shutdown, I can free the prone transforms. It's a very simplistic approach to things. I have a spatial hierarchy explicitly defined, sort of as Unreal has their scene components. I have a spatial entity component, which has a transform and bounds. It also has the parent and the children. Those you might think are cyclic, but this is where I restrict that. So even though a spatial component can access the parent and has its set of children, those are not accessible. They're set private in the base class. Nobody can access them. They're just there to apply, to make sort of hierarchy updates easier. I have all the pointers, so I can basically propagate transforms as I need to immediately. I control the access to those things, like really, it's really restricted. So basically all you have is you have read access to the world transform and to the local transform, and write access through functions, through getters and setters. You don't have a direct access in any way. I also have the world transform, the world bounds cached, primarily because, again, what I've noticed in game code is we generally start accessing world transforms all over the place across objects and stuff. And it's better just to have the damn thing cached instead of just trying to constantly recalculate it or whatever. This is especially true when you start doing AI, where you have to check, like, character positions constantly and those kind of things. Spatial entity components are the only things that are allowed dependencies on other components, and that's built in the system level. And again, it's restricted because primarily it's hard to build spatial hierarchy otherwise. Also, the components in the hierarchy have to belong to the same entity. There's no cross entity references at all. And so we use those to update the hierarchy. It's a very simple thing. Basically, the world transform is recalculated based on the parent and the current local. Whenever you set a local transform, it will propagate downwards to its children. Now, you're going to argue that, okay, if I do that, then I'm constantly updating the children unnecessarily, potentially. Reality is we generally don't have deep hierarchy chains a lot of the time. We also very rarely update the transforms multiple times a frame. And this is kind of in general, it's an unavoidable problem with the deep hierarchies. If you want accurate transforms, you either have to do this, or you basically have to calculate the hierarchy every time you access it. Pick one. They both have pros and cons. So I'm not too sure why I have the slide in here. Anyways, bounds. I just have a simple oriented bounding box on every object. The bounds are not inclusive. They only refer to the individual components. I can't really think of a valid use case for inclusive bounds. And if you really need them, you could just generate them. You have all the information available. You just go through your hierarchy and you can spit out all the bounds and combine them. The hierarchy is basically, as you would expect in a game object component model, every entity can have a single root spatial component. If this seems a bit similar to Unreal, I guess it is, but it's also kind of similar to every other game object component model. They're all kind of the same, and I don't find them necessarily wrong. My issue was fundamentally with their access patterns. So again, this is very similar. You have a spatial entity, you have your updates, whatever. Where things start to differ is that, as I said, there's no updates. Components do not update. Entities do not update. The only thing that can update is what I call systems, which are similar in concept to the ECS systems. Again, they are very much the same concept in terms of it's a component manager that tracks, updates, and transfers data between the components. Entity systems are the only thing that can update and will update. My engine is very simplistic. I'm not a huge fan of task graphs and those kind of things. I find them difficult to reason about and debug. So I just use a very simple approach where I create a set of worker threads and I set the core affinity to them to the actual physical cores. And I have a bunch of buckets per frame where I have frame start, pre-physics, physics, post-physics, frame end, and everything updates within those buckets. And so I have those sync points. It's a very simple approach. There's no dependency chains, task graphs, anything like that. The entity systems themselves will specify what stages they need to run, and they'll say, hey, I need to update pre-physics, and I'll give myself a priority of 65 or whatever. You'll see that priority here. As I said before, it can be annoying to do this, but I have mechanisms that simplify this a little bit. So it's not as much of a headache when you want to deal with this. It does allow me to control the auto update of the systems without actually creating explicit dependency between them. And again, entity systems are not allowed to reference any other entity systems. They are entirely self-contained units. Where my whole thing differs, and again, this is kind of like a academic that took something and just tweaked it. I'm not even going to say that this is anything unique or anything. It's just a twist on a thing. I have the concept of two types of systems. I have local and I have global. There are also conceptually singletons. You're only allowed a single system of a type to be added. And now, what I mean by local and global, local means per entity and global means in the world. So here would be a rough example of that. Like I might have 5 entities, and those green blocks are local systems that are just for that entity. And then I have 4 global systems that operate for everything in the world. Does that kind of make sense? It's like basically, I couldn't find a better name for them because like calling them an entity system is kind of redundant. Entity and world might have been a better name. I don't know. Naming is hard. The local ones are manually added to an entity. So when you build an entity, you'll first set up all the components that entity has, and then you will add the systems that that entity has. Basically, you can think of it as saying, well, here's the data, and these are the updates that I want you to run, if that makes sense. So you kind of explicitly know that, hey, in my entity, I have these components, and I want to, let's say I have an animation component and a mesh component. Well, I want an animation system to run. Add that system in, you know that it has an animation update. It's kind of clear. Why did I prefer priority values to specific prerequisites? Because I don't really use priority that much, and it's generally something that you can kind of set and forget. A lot of the times these systems may not have the need for the priority. The frame update stages are usually good enough. For example, if something's pre-physics and then you run it again post-physics or whatever. Sometimes those buckets are enough to manage your frame. And if you absolutely want a priority, it's there. It's more like a safety net for X cases. Well, we'll get to that, Tamika. It's if you show this to anybody and you say this is an ECS, I'm going to get beaten over the head. So I'm not even going to pretend it's an ECS. It's not. I don't want that army of like angry Twitter programmers yelling at me. So it's not an ECS. Again, systems, they can have transient state. They can have per instance settings. I haven't implemented it. It's trivial to do, but I don't have the need for it. But if I wanted to on the local systems, I could set settings like saying, hey, these are your LOD settings, or these are your whatever distances or whatever. I can put some settings on this actual system as well, in addition to the components. Because sometimes you want, for example, you're doing 2 versions of a feature, and you want to be able to locally switch between the one and the other so that, some director can validate a feature versus the old one. You can put that on the system and have a tick box that says use new feature, use old feature. And then the main thing is that an entity update still conceptually exists, and all it is that the update of the local systems. Right? I still update entities as a unit and as an entity. So I say new character update, and it just runs its local systems. That's kind of how I've defined them. The only thing of interest here is the register. It just takes an entity component and unregister. The other nice thing is in terms of tooling, since the dependencies are explicit, like in an ECS, you can kind of expose it to the user. So when they add an animation system to that entity, it'll basically flag in the tool saying, hey, by the way, you need an animation component, a skeletal mesh component, and a cloth component. And the cloth is optional. So as a new user coming into it, you can kind of like get an idea of, okay, if I want this thing to have an animation update, what is the basic set of data I need for that to work? And those kind of things are simple. So what are global systems? Those are what you would traditionally have in an ECS. They are the ECS systems fundamentally. They operate on all components of a specific type, signature, whatever in the world, and they can have transient run. They are ECS systems. Their primary role is to manage and update world state, and secondary is to actually do cross-entity transfer. Since I don't allow any sort of direct entity references, I do it at the system level. The only difference here with the global entity systems is that when you register the component, you pass in the entity as well, so that at least you can bind, hey, this component is on this entity, so you have that information additionally. Again, really simple stuff. I think I covered this. The only thing that I do kind of tricky here is when an entity is created, it has a list of those systems. I generate per stage update lists. So for every stage in my update, I basically say, this is the set of systems you have to run. Just it's cached so that I don't have to regenerate it every time. And I don't have a loop that says for each component, if you have to run at this state, it's just pre-allocated. And so for every single update stage, we run the entities first, and then we update all the global systems. And that happens for every single bucket. Now, I mentioned that we have no dependencies. One thing to note is we can attach entities to other entities via a spatial attachment. What that means is that once you propagate your transform, it can propagate down to the, the deferral of the, I'm not going to go into like details, but fundamentally, spatial dependencies define scheduling order for the update. So if something has a dependency on another entity in terms of a spatial dependency, the parent is always scheduled to update before the child. And ideally, they will be grouped on the same thread as well to prevent that transformation propagation from potentially not being thread safe, if that makes sense. So by adding those restrictions to the model, it allows me to actually trivially parallelize my entity updates. So what my frame looks like, local are always run before global. So we always run local and then we run the global. That's a fixed rule. If you needed to get data from a global update in a local system, you would then schedule your local system to run it in a subsequent bucket in the frame. And I'll have an example of the data transfer, because I think that part with the examples applies to both my thing and also ECS's in terms of like data modeling and transfer. So the thing that I wanted to do is I wanted to be able to just parallelize my entities trivially. Basically, I just say, fuck it, I have 100 entities, I have 6 cores, split it by 6, run. I don't care. The global systems can go wide. They are like the vanilla ECSs. They can do some work, or they can just run in the main thread. That depends on system to system. The entity lifecycle is also really simple. It has 3 stages: unloaded, loaded, and what I'm terming activated. What activated means is I've enabled it or added it to world or turned it on. And that basically triggers the component registration with the systems, both local and global. So activation basically registers the components with the local systems. It generates a per stage local system update list. That's the kind of list that basically tell you what to run per stage. It then registers the component with all global systems. And finally, it will create the spatial entity attachment if that exists. For example, if you want to attach a weapon entity to a character. And deactivation is entirely symmetric. It does the exact opposite. Now, something that can be really expensive in engines that a lot of people kind of gloss over or they don't think about is that deactivation and deactivation can be expensive. For example, adding to world can be a relatively expensive process. So we want to try to also leverage the cores for this. We don't want to just do it as a single thread. I know in Unreal, for example, the add to world is a big bottleneck. If you try to spawn too many actors or you load a level, you're going to stall out the frame because it fundamentally does that single threaded. So again, I'm just basically trying to fix problems that I've had in the past with other systems. So what we try to do is we parallelize the activation process. And again, the local stuff is trivial because there's no dependencies. I can just parallelize it and there's no issue. Like the other nice thing is of having local systems is you're restricting the amount of components and systems that you have to manage together. So I'm not running every component through every system. I'm just running all the components of an entity across all the systems in the entity. That's a much smaller subset, and that generally runs a lot faster than me trying to send every component to every global system, for example. So again, this is trivial to parallelize, no problem, cool. The global systems are a little trickier because they, again, can affect all entities, and they themselves may have some dependencies in terms of, let's say I have 2 or 3 rendering systems and they all use the render device. You have to kind of take that into account. What you can do there is you would actually schedule the global systems to run. Yes, you can dynamically add or remove components at any point, and it will just check if the entity is already activated. If so, it will activate the component once it's ready to be activated. So you can dynamically add and remove pieces. So what I was saying with the global system, basically we just invoke the logic and we say we schedule the systems and we run all entity components through the systems in parallel. In general, the systems are, again, black boxes, so they should have no interdependencies. And in the case where sometimes they do, for example, I have a skeletal mesh system and a static mesh system, they both use the render device. Potentially, those two will be grouped together on the same thread, just like we do the spatial connections between entities. Again, very simplistic, and it's covered at a systemic level, so programmers don't have to necessarily think about it. They just do their thing. The system doesn't allow them to essentially make mistakes because there's no way to access anything else. Why do I have the distinction between local and global? Fundamentally because we're solving 2 different problems. Local are updating internal state. Basically, it's decisions related to that entity. Can I move? Should I move? How do I do my move? Did I collide with the environment? What should I target? Who's, should I play a sound? All those kind of things. Should I do IK? Whatever. And the global systems, they manage the world state. Now, as I said, the components do have logic. So in a basic example of a local system, we're going to go with animation because I was an animation programmer for most of my career, so it's mostly I'm most familiar with. We could have a simple animation update that basically says, run the animation graph. If the animation graph skeleton matches your skeletal mesh component skeleton, set the pose. And that's my system. Fundamentally, my systems are mostly there to facilitate flow. They will run logic that may generate side effects or outputs on one component, take those outputs and feed it to another component. And the domain-specific logic is kept within those components. So if I want to have a different animation graph component, I can make a different animation graph component. I can derive from it, change the logic, plug it in. The animation system doesn't know. It just runs it, it works. If I want a different flow or different sort of data management, I just create a new animation system, call it version 2, and I add that to the entity, and I remove the first one. Again, I have that control. I can sort of do second versions, side-by-side versions. I can extend, expand, because fundamentally one of the big problems we have with gameplay is that you build a feature, it goes to a gameplay review, somebody says, I don't really like it, can we try blah, blah, blah. And a lot of the times you end up just doing that thing instead of the original one, and that can be problematic because if it doesn't work out well, now you have to go in purpose and revert it back. What I prefer doing is building it side by side. That also makes the next review fundamentally easier because you can switch back and forth between the 2 features. And that makes the whole process better because you can actually do an objective review of, is this better than the previous one? Because you're not using your memory of the previous one, which is usually flawed. You can actually objectively switch and say, yeah, okay, this thing's better, this one isn't. So another thing we can do is we can have multiple mesh components on one entity. And you can expand the system to basically say, hey, I don't know, I wrote some pseudocode here. Don't read too much into that. I necessarily won't do it like this, but you find all the mesh components that match the skeleton, you set the pose on all of them. So if I have my character mesh being 6 pieces, like in a customization system, well, I set the pose on all 6 pieces. But the pose exists once in the animation. I just set the data 6 times, which will set the small subset per mesh. In my actual animation systems, I also store bone mappings because I actually track which components are available. At activation, I generate a bone mapping saying, hey, it's this animation pose, goes to this mesh, and this is the mapping of which bones and which subset of bones I'm transferring. So I track a lot of that data in the system. So they're there fundamentally to transfer data between components, which is to some degree a decoupling that ECS does well, except the ECS also handles the domain-specific logic called the order of, hey, okay, I have my animation system, I get the pose, I can, run the clot, then set this thing on the skeletal mesh component and so on. I can, basically the point here is I can control the order per system if I need to. So let's talk about the global stuff. This is kind of, as I said, standard ECS. So for example, I have a static mesh system that gets all static mesh components registered with it. And when they get registered, I check whether they're dynamic or static. And if they're static, they go into an AIBB tree. If they're dynamic, they just go into an array. For now, as you profile, things will change. And then you can create internally whatever optimization data you need for culling or instancing or whatever. That system then will update once, and maybe it does a rough cull and then submits the draw request to the renderer. Again, very standard ECS stuff. One thing to note, though, is that the global entity systems don't need to directly operate on the data. They can just use the components as signals that something exists in the world. They can basically say, hey, I have a static mesh component. Let me just get the data from it, and I don't give a shit about the actual component itself, right? So we can do kind of crazy things. I'm not suggesting you do this. I'm just saying it's feasible, and it's just an example of something that can be done. You need to profile and check your performance rather than guessing. So in general, my components are dynamically allocated, so they could be anywhere in memory. I have no guarantees about contiguity or anything like that. So I can have an array of component pointers in the static mesh system, and then obviously I don't necessarily want to iterate over that, and all the cache miss stuff comes to effect here. But here, for example, there's a valid argument to be made about the cache misses, because yes, my general operation is go through each one, maybe check if it's visible, and then submit it to the renderer. So yeah, I'm probably going to iterate over all of them, for example. Let's assume it's very naive and it's just an array and it's not an AABB tree or something. Well, what we could do is when we activate, we can allocate a set of proxies that are contiguous. They basically store all the information I need for the renderer, the mesh, the materials, and a transform. So basically I am paying memory here, but I allocate this memory in a block. And then what I can do is I can set a pointer into the component for that proxy. And then whenever we update the transform in that component, it also updates the proxy. So basically we, transparently update the proxies without having to build any extra machinery. Anybody that's ever had to deal with the Unreal proxy system is, holy shit. In this case, it's just simply like whenever I set a transform, I just copy it into that proxy, and that's it. The mesh materials, same thing. And I operate on these proxies rather than the actual components themselves. Should you do this? I don't know. I'm just saying this is something you can do in a global system. You could do the same in an ECS or whatever, what have you. Although in an ECS, it's less beneficial because components aren't being updated by any other system. You are updating them by the system. So there, everything's collated into a single place. Whereas in my case, I still have local systems that may modify the position of these meshes. And so this is one way that the local systems can now update the global system state in a simple way. And because that I am guaranteed that global systems do not run at the same time as local systems, I don't have to worry about any contention of that memory address. I don't have to worry that, oh no, the global system is going to fuck with that thing while I'm writing to it or something like that. So let's talk about data transfer. So AI is another thing that I spent a lot of time working in. And let's say we want to do very basic targeting. So I have some AIs and they want to find the target to shoot at. Let's say we want to define, hey, something that can be shot at needs to have oh, sorry, I'm looking at the wrong slide in the presenter view. Let's talk about stems and then I'll get back to the targeting. Do I plan to That's complicated. I'm not going to go into too much detail, but let's just say I have restrictions based on my contract that I cannot release anything publicly that I work on in my spare time. I'm allowed to work on it. It's all my own code. I have legal permission, all that. I'm just not allowed to publicly release any of it. So let's talk about like stims. Stims is a common problem with AI. Everything can generate stims. Those stims need to be in the AI world, and then sensors will check the world and say what stims apply to me and reflect them into agent knowledge. It's one of the standard problems. So how would you do that? Well, your AI is an entity. It runs some logic. Maybe it moves and it does a footstep and that triggers an event that should now create a footstep stim. This all happens locally within that entity. And what would happen is, well, you could detect the anim event, you create the stim, you register it with your stim generator component, for example, in a list of saying, hey, based on this frame, this is the stims I generate. At that point, your global system can run and it'll say, oh, let me look at all the stim generator components out there and transfer all their data into the AI world. Update whatever stims, timers, whatever we have. And then at a later stage, you can then say, okay, well, now I have all the stims from all the AI. Let me transfer them back to the AI. And then it runs a reflect step where it then can go run and get all the knowledge components and say, well, these are your sensors. This is your knowledge component. Let me set the applicable stims to your knowledge so that you can then run your behaviors at, again, at a local level and not have to worry about global managers or anything like that. If we extend that to something like targeting, so you might want to say, hey, I want to add a target component to any entity that can be shot at. For example, maybe I actually have a target, like a simple static mesh target that I want to do a shooting range. I remember, Mika remembers, there was some pretty horrible hacks we had to do on Hitman to build that target level. And I think I still have PTSD from that, which is why it's a good example. So we add those target components. Again, the global system can reflect all target components into the AI world and say, these are all the things you can shoot at. And then as a second stage, it can also go in and say, hey, for every AI, these are all the targets that are applicable to you based on your sensor or weapon settings or what have you. So again, you have local data going to a global system and then going back into a local state. And then using that target data at a local level, you can then pick a target. You can run your behaviors with all the knowledge you have. You don't need any external data. You have everything you need that's been reflected to you. Yes, you use a little bit more memory, but you can then parallelize all your work trivially. You can run all your AI in parallel. I mean, and that is kind of like a huge thing. So this is what I was kind of talking to. You can kind of like run at a local level. You can say, hey, give me all the targets, filter based on my weapon settings, score the targets based on my behaviors, and then on the weapon component say, hey, you need to fire. Right? So that's another question is, okay, I picked the target, I want to fire my weapon. Well, it's simple. You just have a weapon component, you say, you fire that target, maybe it's got a position, whatever. You fire. Okay. Well, that can go into a global damage system where every frame you get all the queued weapon firing requests, and then you can evaluate all the target components. And then what you can do is you can calculate and apply damage. There is a benefit to doing this this way as well, even if you weren't using ECS or anything like that. In that sometimes, like on gameplay, what you want to do is you want to collect all the damage requests in one frame because there are rules saying doesn't matter how much things you got shot with in a frame, you're only allowed to take 100 points of damage per frame or something. I know that, for example, in a lot of shooters, that's an approach to make it not feel unfair. If you have 10 AI shooting at you, you don't want to take 10 AIs worth of damage. Maybe you only want to take, one AI max worth of damage, and you want to make sure that, like, if it goes over your killing rate, whatever, you have control. Designers can literally come up with rules saying, well, you took 12,000 points of damage from 15 AIs this frame. Yeah, we don't want to immediately kill you. We want to put you on some amount of damage that, won't instantly kill you. So we want to control it, or we want to stagger it or something. Plenty of options there. And again, you apply that and then you send it back to all the local components. And then an AI might say, oh shit, I took 12 points of damage. I'm now dead. And then it can trigger the dying individually. Yeah, exactly. yeah, you're basically deferring it. And so you can do resolution. You can, for example, you can play a hit reaction. You can tell them, hey, you took damage, but it's 0 points of damage. So trigger a hit reaction, but don't actually die, or, whatever. So I'm not going to just speak and be, what's the word? Talking on my ass here. So I'm going to just show you some of it, and we'll look at a profile just to kind of highlight some things. So hold on, if you send it because you're already, yeah, you will send it back because, for example, they might need it. Like health and damage is one thing. So you defer all your damage stuff to a damage system. The AI needs to know that it took damage to trigger a hit reaction, or to die, or to respond in some way, do a bark, something. So you're basically using the global systems to route data between entities. They are basically just manage to say, oh, you did this thing, I'll tell that guy you did that thing, that guy did this thing, you need to know about this thing, and that kind of thing. It's also used for things like the global stuff is also used for like adding things to the physics world, adding nav mesh, what have you. So for example, I guess you can see the screen share. So for example here, when I register a navmesh component, I register a navmesh from that component. And whenever that component gets unregistered, I will unregister the navmesh. I assume everybody can see my Visual Studio. Okay. So I did run this, right? So I have a simple test scene here with 10,000 characters. Every character is basically made up of a mesh with an armor piece and a prop, which is the hair. And then there's also another prop attached. So that was to prove the spatial attachments works. So for example, I think the armor is attached as a separate entity, and the hair is in the actual character. Each one is currently separate and made up of tons of little pieces. So what I'm going to do is let's make a profile. And again, the performance here it's okay. It's like running at like 40 FPS. And so let's zoom out. And what you can see, it's find the main thread. You can see my buckets. So for example, my frame end is kind of long because my rendering is super naive and I don't know what the fuck I'm doing. So I'm just sequentially issuing like 30, 40,000 draw calls. So don't judge me for that. I'm not a render programmer. But my actual like entity updates are all parallelized, and they take roughly like, I think 9 milli. And you can see up here, you can see every single like update entity, which then runs the animation system and whatever else. I've only instrumented some aspects. And you'll see in some cases there's gaps or whatever, but for the most part, I keep the cores busy. And this comes fundamentally for free because I removed the dependencies. And as a gameplay programmer, I don't have to think about anything. I just do my code and I run. Where I do have to worry about things later is obviously the global systems, where I probably need to be smarter and not be a complete fucking moron with the rendering stuff, but I don't know enough there to deal with it, so I'll worry about it later. And that's kind of the idea. It's a very simplified way to kind of reason about the entity model, because what I want to do is I want to have a simple system where a junior programmer can work within the system, can get guidelines for saying, hey, this is where you put this thing, this code does that, this is how your data transfer should work at a system level, and it's something that can be explained simply. There's guidelines. Nobody has to spend 2 hours saying, where do I put this code? Where do I put that feature? Where does that function go? How do I parallelize this? What about that? What about this? that's kind of the idea. It's supposed to be basically idiot proof, because for the most part, that's how I like to code, is basically assume that I'm an idiot, which most of the time I kind of am, and get something to work. And again, this is a very idiotic example, but yeah, it's like I have 10K fully animated characters with spatial hierarchies, updating transforms, and all this kind of shit. It works. I mean, if I got back that like 30 milli of the renderer, it would be running a lot better. But that's for somebody else at 1.2 come in and help me write a renderer. The idea was more the serialization on object model. I also have like I'm just going to see if I can load the map. So yeah, it's like, so I do have like dynamic, you know, adding, creating of entities and that kind of stuff. So it's all like when you register a component, you know, the system has to handle some unregistration tracking. That can be a cost long term. That's one area that I know is kind of shitty, especially for the global systems. When I'm registering like 10,000 components, it has to like figure out, hey, does this component matter to me? If it does, I need to track it, and then when I unregister, I have to find it and remove it. You know, there's stuff to be optimized there, but again, you could use maps as, you know, some decent like hash map or whatever that can speed some of that up. Depends on your access patterns. Again, it all depends how many of those you have, is it slow, and then you optimize. This allows me to also reasonably think about the frame, in that I can kind of like get a good idea of what's going and reorder things as I need to. Hardware wise, I'm running a 3950X with a 1080 Ti. So my GPU is a bit old. But yeah, it's 16 cores, roughly 3.9, I guess. I'm not too sure what the core speed is right now. Finding a situation where complex interaction. So that's the thing about the buckets. You can add as many as you want. They're just sync points. If you need more sync points, add more sync points. You know, like there's many cases where sometimes I do need more sync points because I have multi-stage things that have dependencies. For example, let's say animation. I want to run the animation pre-physics, but maybe there's a ragdoll sim as part of the animation update, so that needs to now straddle the physics update. After the physics update, I want to fire off all the cloth tasks, for example. You know, maybe then I have to wait for the next update. It depends. Again, with the current setup, I think the 5 is good enough, but again, adding it is just adding to an enum and you're good. That's kind of the gist of it. No, not PVD. So that's kind of just an idea, mostly about like what you could potentially do, not necessarily what you should. And I'm not claiming it's better or anything. It's just I find it a nice middle ground of the two approaches. I do not have networking, and I do not want to touch networking. I've been burnt with networking. If I ever make my own game, it's gonna be fucking single player. Jokes aside, networking conceptually is just a replication problem. The components in this case, again, in any system, ECS or game object component, you're basically primarily replicating your component data. So again, you add some replication for the components and you should be good for the most part. What I do suggest is if you do build it yourself, make sure that if you do delta replication, like track what actually changes and don't just say something changed. Question, I'm not clear where attachment updates gun transform gets updated by the hand transform or similar. So the attachments are done in terms of like a spatial update. Basically, like you would have in Unreal, you can set up in the entity saying this is attached to that, that is attached to this, that is attached to that. And that will automatically happen. Whenever you set a local transform, it will update the entire hierarchy. down. So it'll find all children. So if I go back to the, so I kind of have that stuff baked in because I have the pointers in my entity. I have the parent and I have the child. So at any time you say set local transform, it will get the parent world, calculate the world transform, and tell the children, hey, my world transform changed. Update your world transforms. And they will recalculate the whole chain. When we do entity to entity, at that point we have a cross-entity dependency where the parent actually is a component on another entity. So yes, we do have that, but again, it's hidden from the user and it's not something they control. And also when I schedule updates, I ensure that those entities are ordered so that I never update hierarchies on different threads. So for example, if I have a gun attached to a character, I will never update the character and the gun on different threads. When you unload components, that you actually remove all components in a streaming region at once. Well, I unload entities, I don't unload components. So I unload the whole entity, and those entities under the hood, inside of my world, I have separate containers. So what I term maps are basically like prefabs. So I can just unload one chunk of it and all the entities will go at the same time. Yes, it will unload each component and run through every system and say unregistered component. And for the global systems, that can be a big cost. That I'm fully aware of. Again, there is something that I'm still kind of working on. Probably using a map will reduce that cost for the most part. If that answered the question. Spatial updates happens on sync points. No, that it happens immediately. As I said, I am guaranteed that only one thing will be touching the spatial update. So as I said, if I have the character and the gun, I will make sure that the character updates on thread 0 before the gun updates on thread 0. So when the character updates, it will propagate its transform updates to the gun. So it will cross update the gun transformed. But nothing else will be updating that gun at that time because the only thing that can run is entities at that time frame. And I've got that ordering in place to ensure that I don't have any contention. And they're locked to the same thread. The hierarchies are always on the same thread. And I don't allow circular dependencies. So again, there's no issue there. And again, that's why also the global systems run as a separate stage after the entity. So I don't have to worry about overlapping and dependency stuff. It's literally saying this can run here, this can run here. No exceptions, no special cases, nothing. It's basically multi-threading for idiots. Because yeah, I don't want to deal with fucking lock-free shit or locks and other shit like this. Is there any restriction approach related to how systems shall communicate between them in ACS? So as I said, systems cannot reference other systems. What you would use is you would use the components on the entities as cross communication between systems. So maybe you have a targeting system like we discussed and a STEM system. Again, you could put that in the AI system, you could separate them out. The knowledge component will store necessary data for the AI. The weapon system will have information. There could be a component that's a Blackboard component that the AI system can write into. You can use the components on entities to store specific information that other systems need and use the entities themselves as blackboards. So any information that needs to be cross systems, use the entity as a container for that. The systems are fundamentally just, again, their routing and their data transfer. A lot of the actual update stuff is done at the entity level. So for example, all animation, locomotion, movement, all that kind of stuff is handled at the entity level. All that the systems are doing is transferring the data and potentially deferring certain requests or handling stuff in batches like damage or whatever that they need to resolve, like 12 damage requests or whatever else like that. If that makes sense. Yes, I mentioned earlier that at the component level, you can specify whether a component is a singleton or not. And all that means is you can only have one of these per entity. By default, I don't restrict that. But yeah, you could do that. In many cases, I guess it could be useful for things like maybe health, if you want to have a one true health component or something like that. That's kind of one use case for it. Systems by default are singletons. You cannot have the same system twice in a world or twice in an entity. Oh my God, that's been 2.5 hours. I'm so sorry. It grew out of control. Input is a separate system. I have a resource pipeline that's kind of, I can even show you. I have like a resource server that basically handles requests from the engine and then compiles and sends the resources to the engine. And I have a resource system that runs at the start of every frame that basically handles all resource requests, loads them, does all the IO, and sends it back to the, notifies the components, hey, your shit's loaded. So all of my like resource loading code is auto-generated. I have like a custom reflection system using Clang, and all component code is pretty much auto-generated. I'll see if I can find an example of that. Nope. Yeah, for example, like all this code here is auto-generated, and it will send requests for, load, unload, that kind of thing. Yeah, sorry, here we go. Like resource loading, it'll get the loading status of structs and everything else. So all of this stuff's automated and it's run outside of the entity model. Basically, it doesn't belong in the entity model. I will try to upload the stream. I'm also recording it locally because I had an issue with a test stream where YouTube wouldn't put it up on the channel. So worst case, I'll upload it myself, although we'll lose the chat, but it's the first time I'm doing this, so sorry. Ideally, everything will work good, and I'll upload the slides if I can too. Cool. Well, I guess that'll be it. Thank you guys for listening to me blabber on for like 2.5 hours. So how long have I been working on it? 2 years on and off, but it's not actually 2 years. The actual code for this, 2 weeks ish. But it's 2 weeks, but there was a lot of iterations of different approaches, and I tend to be kind of old school where I try to model things on paper. So I spent a lot of weekends trying to draw things out and trying to figure out how to take a problem from work, for example, customization system. How would I build this in an ECS, or how would I do this in a game module? What are the problems that I faced? What are the things that bit me in the ass in the past, like at UB or at IO or wherever else? And that's kind of the hard part. The actual code part is it's maybe like maybe 3 weekends of coding. It's not a lot of code. I mean, I think what my entity's like, it really isn't much code. I mean, the bulk of it is the entity and the component, and it's not that much. Like most of this is the spatial hierarchy updates and like deferral of system activation and that kind of stuff. It's the idea that's important. Code is meaningless at the end of the day. So once you have a good idea. Well, the engine is fuck. That one's a long time. 10 years-ish. It never started out as an engine. It was just more like me trying to learn things. So I mean, I've gone through an editor in WPF, then now my tools are in Qt, and I tried IMGUI for a while, and I fucked around with the resource system like for 2 years, different approaches or serialization, whatever I was interested at the time I was messing around with. So it's like, it's just a experimental thing that I fuck around with. So yeah, it's probably 10 years of messing around with it, but it's not really an engine or anything like that. It's just a framework for trying stuff out. That is a hard one. How do I plan? Honestly, I don't have a good answer for you. I get what they call, oh man, what is it? Something paralysis, like analysis paralysis. Sometimes, like when I don't know how to do something, I literally get stuck and I get frustrated and I get annoyed. So I even put this on hold for a couple of months at one point because I couldn't figure out how to solve certain problems and it was driving me crazy because like I just didn't know how to model certain aspects. And the only thing I would suggest is if you get stuck in that stage, just power through and just write some crap, even if it's shitty, even if it's bad, even if you know it's wrong and not ideal, write it, get it working. In the process of doing that, you're going to inherently build experience and familiarity with the problem. And likely halfway through that, you're going to be like, oh my God, like I'm an idiot. I shouldn't have done this, and just flush the whole thing and come up with a good idea. Exactly. Like you just need to jump in and just like wade in the muck. And at some point, you're going to come up with a good idea. You're going to realize, sometimes you're going to realize that actually, like what you thought was bad isn't actually that, you know, conceptually, it's not that bad. It's just maybe an implementation issue with some approaches. And that's something I think a lot of people miss. There's that expression in English, you miss the forest for the trees, where let's say somebody looks at, let's say, a game that shipped, like an engine that shipped 4 or 5 titles, and then you look at the object model and you say, well, game object component obviously ends up in a mess and it's shitty and this and that, so it's obviously flawed. And we need to knee jerk and do ECS. And that'll solve all the problems. That's not how things work. Because I'm pretty sure if you find an ECS engine that shipped 4 or 5 titles, you can look at it and say, oh my God, this is so horrible. It's unmanageable. It's super slow. It's shitty. There's hacks everywhere. We need to pivot and do game object model. And that'll solve all the problems. There is no perfect solution. The only thing that I aim for these days is making sure that whatever you build from an API or from a systemic standpoint, it's clear how it should be used. That's the biggest problem for junior programmers coming into the industry and stuff. Like they get dumped into like these super complex engines and systems with no information, and then are expected to not make mistakes. And there's literally even, you know, you get those asshole programmers that are like, oh, just read the code and you figure it out. Yeah. How am I supposed to know what's a hack for some milestone and what's the right approach? And what if there's 15 code paths for the same thing because somebody started refactoring and kind of left halfway through or didn't finish, or, you know, it's, you know, ideally you build something that by reading the code and asserting everywhere and doing this whole like fail hard, fail early, you sort of enforce usage that you say, hey, like even if you try to use it badly, it's just going to crash on you until you use it the right way. And slowly people will learn and it'll be comforting rather than just saying, go wild, do whatever the hell you want. Where do you track hierarchy dependencies, then schedule update on set? That is currently something I'm working on. Basically, whenever I apply, you'll notice that I had that stage where at activation time, I create the entity attachment here. That stage is where I create the scheduling information and saying, hey, I'm attaching this to this, so these two need to be linked and make sure that these two get scheduled on the same thread. If that sort of makes sense. All right, I'm not going to take any more of your time, so have a great afternoon and take care.